For 7, it kind of sucks that we're not going to get done with 7-6 before the test, but I guess only to me. The rest of this chapter is devoted to specific types of formulas that you run into in trigonometry. 7.5 is about sum and difference formulas. So what we really want to talk about in this section is what happens if you want to take cosine, say, of some angle plus another angle. Or cosine of some angle minus another angle. That's what we're getting at in this section. And then in the rest of the chapter, the 2 sections after that are more formulas, like, for example, what happens if you want to take cosine of 2 times an angle? Is there a formula for that? Right? Or cosine of half an angle? Is there a formula for that? So this is what we'll conquer today. And this is pretty much what we're going to have to leave until after the test. Now, I put on my notes an example where we actually verify the identity for the difference formula for cosine. But I've learned a giant waste of time. So instead of verifying that identity, I'm going to do a pattern. I'm going to see if you can recognize a pattern here. So let me give you a related example to kind of motivate these formulas here. So suppose I wanted to find a formula. I want to know what cosine of pi over 6 plus pi over 3 should equal. Right, I want to find a formula that has to do with the angles pi over 6 and pi over 3. And I don't have any idea what it's going to be yet. Okay. But I can kind of rule out some of the things that it shouldn't be. Now let me kind of talk about this a little more, because we already know the answer to this. What should the answer to this be?
Square root of 3 over 2.
Now, what is pi over 6 plus pi over 3? Pi over 2. Right? This is right? Pi over 6 plus pi over 3. This is pi over 6 plus 2 pi over 6. Altogether, this will be pi over 2. So whatever we get for our formula, it should be the same as cosine of pi over 2. So I want to kind of draw you a motivating picture here. On the unit circle, where's pi over 6 and pi over 3?
30 degrees.
30 degrees and 60 degrees, first quadrant, right? And you know the sine and cosine values. And this guy is, you do 1, 2, 3, 1, 2, 3, divided by 2. So this is pi over 6, pi over 3. So whatever formula I'm going to come up with, right, this is cosine, right here, right? Cosine is always the x value. This is cosine. So whatever formula I'm going to come up with at the end of the day has to somehow combine these numbers to give me the same thing as cosine of pi over 2, which is 0. So my first question is there any operation I can do to this number and this number to get this number? Like, for example, if I just add root 3 over 2 and 1/2, do I get 0? No. So this formula is more complicated than just adding cosine of pi over 6 and cosine of pi over 3. Because if you add cosine of pi over 6 and cosine of pi over 3, you do not get 0. If you subtract them, do you get 0? Root 3 over 2 minus 1/2? No, that doesn't give you 0. If you multiply them, 1/2 times root 3 over 2, does that give you 0? Is there anything you can do with these two numbers to give you this number? Any combination. The only way you ever get 0 is if you subtract the same exact thing. And so these aren't the same exact thing, so there's no way they're going to combine to 0. Now, what if you include these numbers? What if you include sine of pi over 3 and sine of pi over 6? So certainly I can't combine these again to get 0 because, again, they're not the same thing. They're not going to add or subtract to 0. But what if I multiply these two numbers? You multiply those and you multiply these. What do you get? The same exact number, right? 1/2 times root 3 over 2 is going to be root 3 over 4. And root 3 over 2 times 1/2 is going to be root 3 over 4. And then you can combine those to make 0 by subtracting. So actually, the way the formula works for cosine of a sum is you take cosine of the first number times cosine of the second number minus sine of the first number times sine of the second number. This would give you root 3 over 2 times 1/2. This would give you 1/2 times root 3 over 2, which would give you root 3 over 4 minus root 3 over 4, which is exactly what we want. We already knew the answer we were looking for in this case because we could check it by saying this is pi over 2, cosine of pi over 2 is 0. Now, maybe this convinces you, maybe it doesn't. If this doesn't convince you that the cosine formula for a sum is going to look something like cosine of the first times cosine of the second minus sine of the first times sine of the second. If this doesn't convince you, the book has a proof of this fact, and you're welcome to look it up. But really what I want you to draw from this, more than anything, is that if I give you cosine of one angle plus another angle, it is not okay just to do cosine of the first and cosine of the second and add them together. That will never be true. Okay? If you have cosine of two angles being added, you have to apply a different formula that's more complicated. And here's all the formulas for you. All the possible sum and difference formulas. Here are them. So you can take cosine of the difference of two angles. You can take cosine of the sum of two angles. You can take sine of the difference and sine of the sum. Now, against my better judgment, I will not make you memorize these. Okay, I will give them to you on the test as a little formula sheet, or I'll write them on the board or something. But if you do the homework and you do the review sheet, you should eventually memorize them because you're going to use them so much that you just don't have no other choice. You'll notice that we've switched in this notation. Instead of using theta, we're using alpha and beta for our angles. It doesn't matter, and it's just a variable name. I can replace it with x and y or anything. But the way the formulas work is that the cosine sum and difference formulas don't mix trig functions. The cosine sum and difference formula have cosine of the first, cosine of the second, then sine of the first, and sine of the second. Right? Cos alpha, cos beta, sine alpha, sine beta. The sign in the middle of the two is the opposite of the sign you see here. So if you have a difference formula for cosine, you put a plus in it. If you have a sum formula for cosine, you put a difference in it. And there's no mixing. Cosines stick with cosines, sines stick with sines. For the sine sum and difference formula, you do mix. Right, this will be sine alpha cos beta, so you mix the sine and the cosine. Keep this sign the same, minus sine beta cos alpha. So sine of the first, cos of the second, minus sine of the second, cos of the first. And the last one is almost the same, except plus.
This is all good.
This is all given when you...
What you just wrote will be given to us on the exam?
So, yes, what I just wrote will be given to you on the exam.
Okay.
But, let me caution you. When you have to start doing identities and you have to use these formulas in identities, it's kind of like, how, you know, I could give you all the formulas in the world, but you really have to understand them and remember them in order to apply them when you're verifying identities. So I will give them to you, but I would not let that stop you from really memorizing them, okay? Because it's going to help you on identities. Now, budget your time, right? Memorize them if you have time, and if you don't, you don't. It's fine. But these are kind of right on the cusp of what I think you should know. I really want you to memorize them, but at the same time, I don't want to put too much stress on you. So I'll give them to you, but try to memorize them if you can. Let's work through some examples so we can see how you're going to be expected to use these. So the first couple of examples are just making sure you understand the wording here. They're really just plug and chug, making sure you can plug things in correctly. All right, so it says find the exact value of sine pi over 6 minus pi over 4. Well, that's easy. Of course this is equal to sine pi over 6 minus sine pi over 4, right? No, why aren't you all yelling at me? No. You didn't sound angry, you just sounded sad. No. So sine pi over 6 minus pi over 4, if you want to simplify this, there's kind of two ways to go. You can either actually subtract these angles, or you can apply this formula here. What happens if you actually subtract these angles? What is pi over 6 minus pi over 4? Yeah, so if you do pi over 6 minus pi over 4, you get a common denominator, times 3 times 3, times 2 times 2. So 2 pi over 12 minus 3 pi over 12, negative pi over 12. So in this case, subtracting isn't going to help me any. Because I don't have any clue what sine of negative pi over 12 is. No idea. It's not one of my special angles. So I could try and subtract them and see what happens, but if I don't know the sine of this angle, then this isn't going to help. So really I have to apply this formula to get any traction on this problem. I have no choice. So the way the formula works is you mark your first angle as alpha, and your second angle is beta. Then you know sine alpha minus beta is going to equal. So it should equal sine of alpha, which is pi over 6, cosine of beta, which is pi over 4. Do I include the negative here? Yes. No. The negative is part of the formula. It's not actually part of beta. Right? The negative is in the formula right here. Right? Alpha minus beta. So beta itself is just this portion. So that's why I just put positive pi over 4.
I thought you meant put the negative.
Yeah, so this negative I don't include, but then this negative comes up, right? So this negative from the formula I am going to put. Then sine of pi over 6 again? Pi over 4, you switch them now. Right, so here's my alpha beta. And beta alpha. To match the formula. Alpha beta, beta. But what I've done here is now I have a bunch of different trig functions I can evaluate. Right? I know what the sine of pi over 6 is. I know what the cosine of pi over 4 is. So turn to my handy-dandy unit circle. I know at pi over 6 I have root 3 over 2, 1/2. I know at pi over 4 I have root 2 over 2, 2 over 2. So I should be able to evaluate all this. Sine of pi over 6 is 1/2, right? Y value on the unit circle. Cosine of pi over 4 is root 2 over 2. Minus sine of pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2. It's kind of ugly. So how does this simplify? What does this look like?
Square root of 2 over 2 minus square root of 6 over 2.
Square root of 2 over 4. Remember, when you're multiplying fractions, you go straight across. So this multiplication will be root 2 over 4. And then when you do root 2 times root 3, you get root 6, like you said. And then the denominators are the same, so you might as well combine them. So this is the exact value of sine pi over 6 minus pi over 4. Which means actually we've discovered a new trig value that we never knew before, right? If I come over here and I do sine of negative pi over 12, what should I put for the answer to this now? Root 2 minus root 6 over 4. I just found it. It was written differently, but it's the same. It's the same. Okay. Hardest thing you've ever done, or relatively straightforward?
Hardest thing.
Hardest thing you ever done? Life's going to be rough for you. I want to leave these up so I can erase. Okay. So the next example, a little different, wants you to find the exact value of cosine of 5 pi over 18. Sine, oh no, cosine again, excuse me. Cosine of pi over 9. Plus sine of 5 pi over 18. Sine of pi over 18. Now, initially this should make you feel sad, because you don't know anything about 5 pi over 18 or pi over 9. Right? You have no idea what the sine of 5 pi over 18 is, at least not the exact one. So at first you're like, oh man, this problem's so difficult, what am I going to do? OMG. But then you say, well, maybe this has something to do with those formulas that we just talked about. So is there any way you can apply these formulas to help simplify this expression?
First cosine.
So what the example's asking you to do, the way to find the exact value of this is to first apply this formula backward, right, from right to left. So go this way. Because if you match this up, you have cos alpha, cos beta, right, where this 5 pi over 18 is alpha and this guy's beta, plus sine alpha, sine beta. So this guy is going to match this formula on the right perfectly, with alpha equal to 5 pi over 18 and beta equal to pi over 9. So then this should equal altogether, after applying the formula, what? Cosine of 5 pi over 18 minus. Is that it?
No.
Oh, I want the exact value of that. I mean, that's good. That might help me. But now I have to somehow figure out what this equals. So maybe you actually subtract these numbers. Right? Your common denominator would be 18. So times 2 times 2. So this is actually cosine of 5 pi over 18 minus 2 pi over 18, which is cosine of 3 pi over 18. Whoa, that's amazing. 3 pi over 18 reduces to pi over 6, which I know the cosine of. Whoa, so cool. Dang, Josh, you're the best math teacher ever. Thank you, student. You're the best math teacher ever. So, basically, this is going backward. Right? It's just to help you recognize that you can go both ways with this formula. Practically useful? Probably not, but helping you recognize you can go both ways. Questions? So up until now, we've only been able to find sine and cosine of our special angles, 30 degrees, 45 degrees, and 60 degrees. Right? Something like cosine of 15 degrees has eluded us. But we can calculate it now. Right, so how would you do this example? How would you calculate the cosine of 15 degrees?
We could take like the cosine of 60 minus 45.
Yeah, so again, because you know some difference formulas now, this is the last thing we talked about, I would try to make use of these formulas. So rewrite your 15 degrees as a sum or difference. So for example, you can rewrite 15 degrees, if you're clever, as 60 minus 45.
What about, just 15 plus 15 to get pi over, to get 30 degrees, I mean.
15 plus 15 is equal to 30.
Yeah, and so you get 30 degrees, which is one of the special angles, isn't it?
Yes.
We could also do that, or no?
But how would cosine of 15 plus 15? See, that would equal cosine of 30.
I wouldn't get us anywhere.
But how would you use it to solve for cosine of 15? I mean, because when you break this down, you're going to have a sine of 15 and a cosine of 15, which you don't know how to evaluate.
Right.
So this is,
So we need,
it's a more indirect thinking. You want to think of two different angles, two angles that you know something about, that add up to, or add or subtract to 15.
so we have to break it up into two special angles, not have them equal. as
Right,
special
right, not
angles.
have them equal.
So I
especially.
approached it wrong.
Correct, you're going in the opposite direction.
Okay.
Are these the only special angles I can use? Can I do something else?
Do 30 minus 15?
Yeah, so maybe you think 30 minus 15. Does this work? No, because you still have the 15 in there, right? But you could do, I heard another one, 45 minus 30, that would work, right? Because both of these are special angles. So you just play around until you get the right combination of special angles. That, just any two special angles that give you 15, and then you apply your formula. So the difference formula is up top again. So this is equal to cos 60, cos 45, plus, right, you change the sign for the cosine difference, sine 60, sine 45. And the problem's pretty much done, right? Because you know about 60 and you know about 45. So cos 60 is 1/2. Cos 45 is root 2 over 2. Sine 60 is root 3 over 2. Sine 45 is root 2 over 2. Do the multiplication. So you're going to see lots of root 6s and root 2s and 4s. You'll see different signs on all of them, but you'll see a lot of those numbers because they come from these numbers. Jazzed, pumped. So, one more of this type of example. I haven't beat that dead horse enough. Take it a couple more times. Find the exact value of sine 11 pi over 12. What's the strategy?
Change the 11 pi over 12.
Yeah, so you want to change 11 pi over 12 into special angles, right? Now, in order to do that, are you going to convert to degrees and then do it? No, good. Good students. That's what I like to hear. So I'd like to, because I hate degrees, I'd like to keep this in radians. So I'm going to need to convert this to two special angles that add up to 11 pi over 12. Kind of a pretty easy trick is to say, well, if you want to add up to 11 pi over 12, your denominators have to both be 12. And you have to have a pi on top. And then you just fill in numbers in front of the pi so it adds up to 11. So for example, I could put a 6 and a 5 here because 6 pi plus 5 pi will give me the 11 pi on top. Should I put a 6 and a 5 there? No, why not?
Because you almost have
You don't know anything about that.
I don't know squat about 5 pi over 12. I don't know what sine or cosine of 5 pi over 12 is. So you want to pick something that will reduce. So pick something for me.
8 and 3.
8 and 3. Those sound like winners. This I like. 8 pi over 12 plus 3 pi over 12 is absolutely 11 pi over 12. But these also reduce. Right? 4 goes into both of these, making it 2 pi over 3. 3 goes into both of these, making it pi over 4. Now we're in special angle land. Woo!
2 times pi is a special angle.
Absolutely. It's like a special angle of pi over 3. It's got a reference angle of pi over 3, so we know about it. Right? 2 pi over 3 is up here. And pi over 4 is up here. Pi over 4. So it's on the unit circle. We know, let me write it since I drew it out here. We know this guy's root 2 over 2, root 2 over 2. 2 pi over 3. What do you think here? 1/2 comma root 3 over 2. Missing a sign, I think. Cosine's negative, so negative 1/2. So this is your special, or this is your unit circle. XY value for 2 pi over 3. So when we break this down, first we apply the formula, then we go to our unit circle. Alpha plus beta. Alpha plus beta. So I'm going to go, tell me what to write here. This equals what? Sine of 2 pi over 3. Cosine pi over 4, right? Because we're applying this guy right here. Sine alpha cos beta. Plus
Sine of pi over 4.
sine of pi over 4, yeah.
Cosine 2 pi.
Yeah, so you switch the angles for the second part. apply my formula, and then each individual sine or cosine I know here. And sine of 2 pi over 3 lands in the second quadrant and gives me root 3 over 2. Cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is root 2 over 2. And then cosine of 2 pi over 3 is negative, right? You have to include the negative. Just multiply out. Root 6 over 4. It's not negative. Root 3 times root 2, root 6. 2 times root 4. This side will be negative though, right? Because it's a minus times a plus. So minus root 2 over 4. Okay. Questions? I think this is way too concrete. We have to get more abstract for you now. I like having these formulas written over here.
So the answer is always going to have 2, 6, and 4 for these kinds of problems.
Likely.
Yeah, let's put it that way. It's likely. Whenever you ask me a question of the form, so the answer is always going to be like this. In my head, I think, how can I make the answer not like that? And then I put it on the test. So, yes, usually it's going to have these numbers just because if you look at all the possible ratios on the unit circle, this is what comes
So
up.
if I get anything other than those numbers, I probably
Yeah, you might want to check your work, yeah.
It's a bunch of
That's where I was getting at.
Yeah, if you're working this type of problem and you get something else, you should definitely question it. All right, let's try something a little more abstract. Use the given conditions to find cosine alpha plus beta and sine alpha plus beta. We'll do one. So I give you sine of alpha equals 4/5. And then I tell you alpha lies in quadrant 1. That's what Q1 stands for, quadrant 1. Then I also tell you sine of beta is 7 over 25. And beta lies in what, quadrant 2? I want you to find somehow cosine of alpha plus beta and sine of alpha plus beta. Now, the only thing I know about cosine of alpha plus beta, see, I don't have a specific alpha. I don't know what alpha is. I don't know that it's 135 degrees or that it's 45 degrees. I have no idea. I know it's in quadrant 1, but that's it. So, since I don't know what alpha is and since I don't know what beta is, the only thing I can really do here is try to apply the formula and hope everything works out nicely. So what I want to do is write out my formula. Cosine of alpha plus beta is cos alpha cos beta minus sine alpha sine beta. And see if I can somehow discover these values through the information given. So for example, sine of alpha is given. It's 4/5. So I already know this part of my formula here, this whole sine of alpha is 4/5. sine of beta is 7 over 25. So this whole sine beta I can replace with 7 over 25. What I don't know are the cosines. These are my unknowns at this point. So how can I use this information to somehow figure out what cosine alpha and cosine beta are? Draw a triangle. Absolutely. If you have sine and you want cosine, you can draw a triangle as long as you know what quadrant you're in. Let's see. For alpha, I know alpha is in quadrant 1. So I can draw a triangle in quadrant 1. And how would I label this triangle? Yeah, sine alpha is 4/5, but I know sine is opposite over hypotenuse. So I'll label the triangle by putting 4 for my opposite length and 5 for the hypotenuse. And then solve for the adjacent length. What is it? 3, Pythagorean theorem. 5 squared minus 4 squared. Square root. So then I can actually calculate cosine of alpha. What should it be? 3/5, adjacent over hypotenuse. So then I know this. Right, I've calculated this portion of my expression. So I'm almost done. Now I just need beta. I mean cosine of beta. Beta is in quadrant 2, so it's going to be a slightly different triangle. Right? Beta ends up over here. This guy's bigger. How do I label this guy? Again, I use sine. I know sine beta is equal to 7 over 25. So I know opposite, I know hypotenuse. Opposite, hypotenuse. That's P. Opposite is 7. Boom. Take that opposite. Hypotenuse is 25. Boom. So then how do I solve for that adjacent length there? Pythagorean theorem. So you do 25 squared minus 7 squared, and then take the square root. You know what you get? 24. Now, is it going to be positive or negative?
Negative.
Negative because you're going in the second quadrant. You guys are all over that negative. That's what I like to hear. Glad you can't do that on a test, huh? I'm sure you'll all get it. So cosine is adjacent over hypotenuse. So that's what we can put here. And then it's just, now it's just a matter of doing the grunt work. I know cosine alpha plus beta is equal to this expression, so then I plug in my 3/5. I multiply it by my negative 24 over 25. Then I subtract 4/5 times 7 over 24. See, this looks like negative 72 over 125 minus 28 over 125. Ooh. So negative 100 over 125. So if you reduce 4/5. Oh my God, that was a lot of work. So angry. So cosine alpha plus beta is equal to negative 4/5. What about sine alpha plus beta? Do we have to do lots of work? No, we've done most of the work. All right, we found the missing quantities. The missing quantities were cos alpha, cos beta. We found both of those. Now we just have to apply the sine formula to get sine alpha plus beta. So that'll be cos alpha, the formula for sine alpha plus beta is sine alpha cos beta minus sine beta cos alpha. Just plug it in.
It's plus.
Oh, good eye. Yeah, it's plus. You don't change on the signs. I mean on the SINEs. Cool. So let's plug it in. Let's see, so sine alpha, 4/5. Cos beta, negative 24 over 25. Sine beta, 7/25. Cos alpha, 3/5. Get it all out. Negative 96 over 125. Plus 21 over 125. Negative 75 over 125, it looks like. Reduce 3/5. So in these types of questions, kind of the format is you're given one trig function and information about an angle, then you're given another trig function, information about a different angle, and you're always going to have to draw two triangles to get the missing information. One for alpha, one for beta. If you look down here, it's the same type of problem. I'd rather do the identity so I won't go through it, but you have alpha with information about alpha. By the way, what does pi less than alpha less than 3 pi over 2 mean? What quadrant is that?
3.
3. Right? Because pi is here, 3 pi over 2 is here. So this is another way of saying alpha is in quadrant 3. And then you know tan alpha is 3/4, so you can draw your triangle. Cosine beta is 1/4, and then what quadrant is beta in? Yeah, 3 pi over 2 and 2 pi. 3 pi over 2, 2 pi. So that problem is essentially the same thing. You're going to have to do all the same work, draw two triangles, fill in the missing quantities. So I won't do that, but I do want to ask you one other question about this one. What if I were super mean? It's not really that mean. What if I were pretending to be super mean, and I also wanted to know tangent of alpha plus beta?
Don't you just put those on each other?
Yeah. So once you have cos alpha plus beta and sine alpha plus beta, tangent of alpha plus beta is nothing. Right? It's very easy. You just do sine over cosine. Tangent is forever and always sine over cosine. So if I happen to ask for tangent, you can just divide these two answers. Sine over cosine. So when you flip and multiply, you get negative 3/5 times negative 5/4. So 3/4. there is a formula actually for tangent of alpha plus beta. I'll show it to you at the end. In this case, it would be a really huge waste of time to use the formula, though, since you already have information there. But there's a formula for this. We'll get to it at the end. So, in the last 20 minutes, I will do some identities using these angle sum and angle difference formulas. So this will give us some identities. Verify each identity. Sine of x plus 3 pi over 2 equals negative cos x. So this is what I want to check. I want to make sure this is true. I don't believe it. I'm going to check, right? That's how you're going to do all your identities. I'm smarter than you, Jim. So how can we, what side do you want to start on here? How can we start this proof? Let's start on the left, because there's not really anything you can do on the right. I mean, cos x is pretty much simple. But if you start with sine x plus 3 pi over 2, what can you do with that? Yeah, you can use your formula to expand it. You know somewhere in your memory banks or on a paper or in a book that sine alpha plus beta, sine alpha cos beta plus sine beta cos alpha. This is your formula. It's been given to you. You're allowed to use it however you wish. So in this case, alpha will be x, and beta will be 3 pi over 2. So I will write this as sine x cos 3 pi over 2 plus sine 3 pi over 2 cos x. Okay, so what does this mean? Can I do anything with this? Yeah, so the angles that aren't variables, I can actually evaluate cosine and sine of. Right? I know what cosine of 3 pi over 2 is. What is it? 0. Right? Cosine of 3 pi over 2 means you're down here, and the x value is 0. So I can actually evaluate this to 0. And I can evaluate sine of 3 pi over 2 as well. What's that? Negative 1, the y value on the unit circle. So instead of writing cos 3 pi over 2, I'll write times 0. And instead of writing sine 3 pi over 2, I'll write times negative 1. And then, you're done, right? Now you can put your check. Right? Because sine x times 0 is just 0, right? This is gone. And negative 1 times cos x is just negative cos x. So it checks out. Yeah, I'm okay. I'm okay with doing good.
Is putting the 0 necessary, or?
If you mean, will I kill your family if you don't put the 0? Probably. I mean, if we're being honest.
Well, would it right if I didn't put the 0 this time?
Where? At some point you have to put
The
0.
answer.
Somewhere.
In the answer.
The answer to an identity is the steps.
Oh, okay. So
So,
you do
now-
want the 0.
No. I'm saying this is not the answer. You show me what you need to show me for your logic. If you don't need this, you don't have to put it. Okay, but it's whatever you need to get from here to here. There's no one answer for an identity. So
So if I would have just put negative cos x, would I have gotten it wrong?
You just need to show me you know what's going on. You just show me that you can get from here to here. If you drop to 0, I understand that. I'm okay with it. Let's do the last two here. So B, cos pi minus x is supposed to equal negative cos x as well. How would you prove this? More of the same, right? Start with the left. But now you have to apply a cosine difference formula. Right? This is alpha. This is beta. You have alpha minus beta. So the cosine difference formula says that cos alpha minus beta is equal to cos alpha cos beta. Now the sign changes, plus sine alpha sine beta. So this is the guy I'm going to use. So I'll write cos pi cos x, cos alpha cos beta, plus sine pi sine x. And then, now you evaluate what you know. Right, somewhere in your head you know that cosine of pi is equal to what? Negative 1. And sine of pi is equal to 0. Negative 1. So you're done, right? The next line, if you're so inclined, you may write negative cos x and drop the 0 because plus 0 doesn't change it.
I have a question.
I have an answer. Let's hope they match.
I'm confused how you got the answer so quickly. What I'm saying is now that you turn negative 1 cos x plus sine x, what'd you do with the sine x?
Right, yeah. I hate it when students don't show their work. Okay, so we'll put negative 1 times cos x plus 0 times sine x, because that's what we have here, right?
Yeah.
What's 0 times anything?
Oh, 0.
So then we're just left with negative cos x.
It's fun putting check marks.
All right. I feel like you've accomplished something. So, could you verify then, call this b and a half. If I asked you to verify cos pi minus x equals sine x plus 3 pi over 2, could you do that?
Sure.
How would you do that?
Start with one of the sides and use the formula to figure it out. Should we start with the, I guess it wouldn't matter for every day.
So let's start with cos pi minus x. What would be your first move here if you were trying to verify this formula? This equals what? Negative cos x. Why? Because we just proved it. I know cos pi minus x equals negative cos x. That's what I just proved. Part B. How's that help? Well, negative cos x is equal to sine x plus pi over 2. By part A. Or 3 pi over 2. And then you're almost done. have them put the check, so. That's good. So sometimes I just be aware of this. You can combine, you can use your previous results, right? Once you verified something, you can use it on the phone. Right? All right, one more. So far, they've been pretty straightforward, right? Let's see if we can keep it that way. Whoa, 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 this guy's got X's and T's. Craziness. Super crazy. Sine x plus t plus sine x minus t is supposed to equal 2 sine x cos t. Get out. No way that's true. How do we do it? How do we verify it? Where do you think we should start? Right side? No, there's nothing to do on the right side. You can't break this down any. Start with the left. It's pretty complicated. See what you can do. So start with sine x plus t plus sine x minus t. And then do what with those? Cancel the t's, right? T minus t is 0. Can we do that? No. No. I had a hard time even saying that.
Yeah.
What can we do though?
Expand.
Use your formulas. Right, you have a formula for sine alpha plus beta. Pull it up here so I don't have to write it. Sine alpha plus beta. There it is. So it'll be sine alpha cos beta plus sine beta cos alpha. So I'm going to do sine x cos t plus sine t cos x. So that's what I get when I expand this side.
I'm going to cancel things. You want to get to the next step?
I hope so.
Okay.
Otherwise we're going to be up a certain
Wanted to predict
creek
it.
without a paddle. Then I have plus, so I recopy my plus. Then I do my formula for alpha minus beta, sine of alpha minus beta. So let's see, sine x minus t will be sine x cos t. But then since it's a minus, you'll put minus sine t cos x. So that's the formula when you expand x, sine of x minus. So I just circled them to show you where they came from. Like this guy came from the formula for sine x plus t. This guy came from the formula for sine x minus t. Now let me write it without those annoying bosses. So what happens? What cancels? Second and fourth. So we have a sine t cos x and a negative sine t cos x. So 1 sine t cos x minus 1 sine t cos x, these are going to go to 0.
So now we have two of those.
And then the only thing you have left are exactly the same term. Right? You have a sine x cos t plus sine x cos t. So if you combine these together, 1 plus 1 will give you 2 sine x cos t. Check.
With the sine x cos t.
The last thing I put on these notes is the formulas for tangent. So so if you want to copy those down so you have them, or they're in your book. Then, the tangent does have sum and difference formulas. I don't have any examples planned for them because they're just formulas and you should be able to figure out how to use them. If you have problems in the homework or in the review, let me know and we can go over them. But be aware they exist and hopefully try them on the homework once or twice. But that's it. That's all I have to say about 7 and 5. Okay? So go home, work the homework, work the take-home quiz, work the review, and bombard me with questions on Monday.